Good morning and Assalamualaikum to the fellow panel. My name is Muhamad Idzwan Hilmy bin Amiruddin from 4 BMFG Section 2, which under the supervision of Professor Sivarao. And today I'm going to present to you about my PSM1, which is called Heuristics Modeling and Optimization of 3D Printing Process. To have a nice flow of presentation, I make a presentation outline for this project. It is important to understand first what heuristic actually means. So, heuristic is any approach to a problem solving or self-discovery that employs a practical method that is not guaranteed to be optimal, but is sufficient for reaching a short-term goal. There are many methods available in the 3D printing process, which is called Taguchi method, RSM method, and the finite element analysis, which I will be using for this project. The aim of the research is number one, to develop a finite element analysis model, which is capable to predict the quality and the performance of the 3D printed parts. Before anything else, let we understand the basic 3D printing steps. Number one, the blueprint of a 3D object is created using computer modeling software. We can create any parts desired in any software like SolidWorks, CATIA, and many more. And then the drawing, we must convert it into an STL format. Then we're using a process called slicing. The model is divided up into the horizontal layers. And the most famous slicing software is called Cura Slicer. Next, once the software slice, the dimension of the layers are sent to the printer. And then we can set the parameters by ourselves. Like example, we set the infill percentage of the desired part 100%, 50%, and anything else. And number four, the object is built by adding or printing one layer on top of another until fully formed. It does this by melting plastic and depositing it into the printer platform, as specified by the design, where it instantly cools. The problem statement. In 3D printing, it is required to have a nice quality of a printed parts output. Unfortunately, since the pieces with varying measurements are printed for different reasons, number one, the problem that encountered are it needs a highly skilled personnel to alter the processing parameters. We have many different parameters in the 3D printing process, like nozzle size, determine the infill density, and the printing temperature, and many more. Unfortunately, since the printed part with varying measurements are printed for different reasons, it takes highly trained workers to adjust processing criteria in order to preserve the responses of the printed parts to its specification. Number two, next, it will require a huge amount of time and material will be lost while the system is running on a trial and error to achieve the desired efficiency and performance. I've also attached several images of the defects in the parts itself, like under extrusion, over extrusion, holes or gaps in top of layers, stringing or oozing, and many more. This problem happens because the parameters that are not suitable for the printing process. You can visually see all the defects in the desired parts. The objective of this report, number one, to perform a preliminary investigations on the modeling process of 3D print. Number two, to develop and optimize finite element analysis model. And number 3, to experimentally validate the finite element analysis model. Next, the scope. Number 1, the utilization of the tabletop 3D printer. Number 2, by employing FEA modeling tool using commercially available software like Scatia or SolidWorks. And next, the using of ABS as the additive material. Literature review. Here are the 3 related research for my project title, and I will explain it one by one. The number 1, from James A. Gopsil. The title is Using a Finite Element Analysis to Influence the Infill Design of Fused Deposition Model Parts, and published in 2018. From this research, the key feature of the proposed process, which is finite element analysis, and its ability to generate FEA influence infill for complex parts with multiple parameters chosen and 3-dimensional loading conditions. The result, we can confirm that by using the finite element analysis, it can influence the infill design outperforms the hexagonal structure in supporting higher loads. Number 2, the finite element analysis influence the infill provided substantial increases in strength in situation where the stress profile is less distributed across the part to be printed. Number 3, it influenced the infill design generally saw a reduction in covariance at which the maximum loading point occurred. And finally, it can, by using finite element analysis, it can influence design a consistent parameter buckling event, which commonly occurred at the same level. Number 2, a research on 3D printing assisted finite element analysis for optimizing the manufacturing parameters of a lumbar fusion cage by Elena Provagi in 2019. So in this study, the researcher combined the use of 3D printing with finite element analysis to enhance the understanding of certain manufacturing parameters like the material, the infill density, infill pattern, and the outer vertical shell. Accordingly, the printing accuracy, repeatability, and the mechanical behavior of porous 3D printed structure were investigated, and the experimental coprocess modulus values were used as input for the finite element analysis. Overall, from the chart, you can see that the porous structure fabricated with honeycomb patterns exhibited higher dimensional accuracy and higher compressive properties than rectangular structure. The result indicates that both PC and ABS can be adopted to fabricate a porous cage with a 50% infill density and a honeycomb infill pattern. The result from this analysis, number 1, the time step has a large influence on the local temperature distribution during the printing process, while it has a minor influence on the mechanical analysis results. Number 2, the meshing strategy from the software, from the drawing software, is important to reproduce the real printing process. And finally, the model must be calibrated with accuracy because in particular, temperature dependency of Young modulus and yield stress limit must be taken into account. Next is the methodology flowchart of this project. We started by a problem statement identification. And next, all the related literature review on heuristic modeling and optimization of 3D printing process. Then we do the preliminary investigation, which my objective 1 is achieved. The preliminary investigation conclude all of this finite element analysis, like the types, the characteristic, and the application of finite element analysis. And all of these investigations are required to design the parameters. Then only we can develop the finite analysis model, finite element analysis model, which my objective 2 is achieved. So how the finite element analysis is developed is by experimental setup and the existing modeling from the related paper. And then we make a data collection of these two modeling and compare the results, then do the validation tests on like stress strain analysis, Young modulus, and many more. And finally, the Gantt chart for my PSM1. From week 1 to week 3 is the project briefing, discussion with the supervisor on the title for final project 1, and identifying objective, scopes, and problem statement in proceeding on chapter 1. From week 4 until week 9, I make a literature review and research about all the project parameters that are related towards the topic. From week 9 until 10 is for the submission of student logbook. From week 7 until week 13, analyze and planning the methodology of the project. Week 14, make a poster presentation of FYP1. And week 15, the FYP1 report submission. Thank you.